Hello, Pre-Calculus 11 students. This is Lesson 5 of Trigonometry. It's called Trig Ratios of Any Angle. I'm going to call mine answer key. So suppose theta is any angle in standard position and p x comma y is any point on its terminal at a distance r from the origin. So let's say it's in here, for example. This is the point px comma y. And the angle is measured from the initial arm, which is on the x-axis like that, to the terminal arm. This is angle theta. Okay, and the point is a certain distance r from the origin. You know how the origin is 0, 0. And just as a little aside, the reason we call it r, guys, is because you can sort of think of this point as going around in a circle, right? And you can see then that that distance would be the radius. So that's where it kind of makes sense to use the letter r. Okay, and so the primary trig ratios are defined in the following ways. Sine of that angle would be y over r. Cos of this obtuse angle is x over r. And tan is y over x. Okay, and so these are kind of the real definitions of the primary trig ratios. We're kind of used to SOHCAHTOA, but SOHCAHTOA is really just a special case of these more general definitions. SOHCAHTOA is just a special case of these definitions down here. Okay. And another formula that we can come up with is if we look at an angle in the first quadrant, okay, the angle is here. We can kind of make a 90-degree triangle, right? I should have this dot more back here. Okay, and then notice to go out the horizontal distance, this length is x, and to go up the vertical distance, this is y, and we have a nice 90-degree triangle in quadrant 1 there. And when you have a 90-degree triangle, then Pythagoras applies. And so we get this formula that r squared is equal to x squared plus y squared. Okay, and that actually holds throughout because you can make a 90-degree triangle in any of the quadrants. Okay, and so that's another formula. And so this next little section is determining the sign of the primary trig ratios. And we'll look at 4 situations in each of the 4 quadrants. This is R, this is angle theta, and this is the point x, y. Okay, and so sine theta, according to the definition up above, is y over r. And what we're going to do, guys, is we will look at the signs of each of these letters, whether they are positive or negative. And so in the first quadrant, if we have the angle like this, notice that the y-coordinate is up there. It's above the x-axis, so the y-coordinate is positive. And r is the radius of the circle. It comes from x squared plus y squared, and so r is always going to be positive. So what we're going to get for sine theta is a positive divided by a positive, which would give us a positive result. Okay, so sine theta is positive. Cos theta, according to the definition, is x over r, and notice that the x-coordinate is this way. It would be a positive x, and the radius is positive, so cos theta is positive as well. And tan theta, by definition, is y over x, and we saw that the y-coordinate is positive because it's above the x-axis, and the x-coordinate was off to the right, so it was positive, so we get positive for that as well. And oh, I was going to pause for a second because there was a lawnmower going past, but it's okay now. Okay, so now we'll consider what happens when your angle is in quadrant 2. So you're off over here. We've got this point x, y, and so now we're talking about this angle. And of course, that is r. Sine theta is y over r. The y-coordinate is still up like that, so the y is positive. The r is always positive. So in the second quadrant, sine theta is positive. Cos theta, by definition, is x over r. We know that the r is always positive. But look at the x-coordinate this time. The x-coordinate is negative, right? Because you have to go to the left of the origin. The x-coordinate is negative. Negative divided by positive is negative. Okay, so cos theta is negative in quadrant 2 here. And tan theta is y divided by x. The y-coordinate is positive. The x-coordinate is negative, so we get a negative for tan theta. Okay, and so now we'll see what happens when we move the angle into here. There's r. And again, sine theta is y over r. And look at the y-coordinate this time. It is down below, right? So the y is negative, r is always positive, and so negative divided by positive would give us a negative result. Cos theta is x over r. And look at the x-coordinate. We'd have to go off to the left. So negative direction, the r is positive, and we get a negative result. And finally, tan theta is y over x. The y is negative. The x is negative, so we would get a tan ratio that is positive. And we will do this one more time with an angle all the way around like that. Sine theta is y over r, so remember the point is xy, the radius is r there. The y coordinate is negative, r is positive, so we get sine theta as being negative. Cos theta is x over r, so look at the x coordinate. You'd have to move off to the right, so the x coordinate is positive, the r is positive, and positive divided by positive is positive. And tan theta is y over x. If we look at that xy pair, the y coordinate is negative, the x coordinate is positive, giving us a negative result. Okay. Okay, and so this helps us to develop what is known as the cast rule. Here it is shown below. And the cast rule goes like this: C-A-S-T. And that comes from the following. Notice, guys, in the first quadrant, this first column that we did, all of the trig ratios were positive. So the A stands for all. All trig ratios are positive. Okay, so the A stands for all. In quadrant 2, check out this situation. The only one that's positive is sine. So the S stands for sine. Just sine ratio is positive. In the third quadrant, we had these situations here. The only one that is positive is tan. So the T stands for tan. Just tan ratio is positive. And in the fourth quadrant, we had negative, positive, negative. It was just cosine. So the C stands for cos. So just the cosine ratio is positive. Okay, so we've got all trig ratios positive in the first quadrant, just sine is positive in the second quadrant, tan is positive in the third quadrant, and just cos is positive in the fourth quadrant. Alright, so let's do some examples. Example 1, the point negative 8, 15 lies on the terminal arm of an angle theta in standard position. Determine the exact trigonometric ratios for sine, cos, and tan. Okay, so negative 8, 15 would be somewhere up like this. And it forms this angle theta with the initial arm. And it wants to know the exact trig ratios for sine, cos, and tan. Sine theta is y over r by definition. Cos theta is x over r. and tan theta is y over x. So the only one we can figure out right now is tan theta, because you can see that the y-coordinate is 15 and the x-coordinate is -8. So we could write that as -15 over 8. That's the tan ratio. Okay, to get sine and cos, we need to know r. We need to know what is r? The radius, right? And just for simplicity here, I just want to knock off any extra stuff on the diagram. Okay, but we do have that formula, right? X squared plus y squared equals r squared. So -8 squared plus 15 squared equals r squared. So r squared is equal to -8 squared in brackets plus 15 squared, and we get 289. So r is equal to plus or minus the square root of 289. We're going to drop the negative because r is a radius. R equals 17. Awesome. So sine of angle theta, which is this big angle right here, right, is y over r. The y is 15 and the r is 17. And cos theta is x over r. The x-coordinate is -8 and the r is 17. Okay, and this shows for us a bit more about the cast rule, right? You know how it goes cast like this? So we should expect that just sine is positive in that quadrant. And if we look at our ratios, guys, notice that the sine ratio is the only positive one, 15 over 17. The other two are negative. Okay, so that reinforces the cast rule for us. Okay, so that's example 1. Example 2 says, suppose theta is an angle in standard position with terminal arm in quadrant 3, and cos theta is equal to -3 over 4. What are the exact values of sine theta and tan theta? Okay. So we ultimately have to determine x, y, and r. So it says we have theta is an angle in standard position with terminal arm in quadrant 3. Quadrant 3 is over here. So we have some angle like this. X, Y, and R. Just writing the quadrants for you. Now, cos theta is equal to x over r, and they are telling us that that is -3 over 4. Now, the radius is always positive, so that 4 would have to be positive, and the negative would have to be for the x. Okay, and that's okay because that x-coordinate is negative. Okay, so we've got -3 there. We have an r of 4. And we just have to figure out what y is. So we'll use that Pythagoras formula. X squared plus y squared equals r squared. So we will have -3 squared plus y squared is equal to 4 squared. So this is 9 plus y squared equals 16. Subtract 9 from both sides and we will get y squared equals 7. So then y is equal to plus or minus the square root of 7. And is it the positive or the negative? Well, look at the y-coordinate. Y would have to equal -√7. Okay, because the point is below the x-axis. It's in the negative y direction. So there's y. And now we can figure out sine theta and tan theta. Sine by definition is y over r. The y is negative root 7. The r is 4. So there's the ratio for sine theta. And tan theta is y over x. So we would get negative root 7 over negative 3. Negative divided by negative is positive. And there's our expression for tan theta. And again, if we check out the cast rule, the only one that should be positive in that quadrant is tan, and that's what we get for our ratios. Okay, notice that the cos one is negative, sine is negative, the tan ratio is positive. Okay, so now I'd ask you to recall the special triangles. These gave us the exact values of the trig ratios sine, cos, and tan for the angles of 30 degrees, 45 degrees, and 60 degrees. These are shown below. So these were the two special triangles. The 1, 1, root 2, which is 90, 45, 45. And then there was this other triangle, which goes 1, 2, root 3, and it was the 30 degree, 60 degree, 90 degree triangle. So we can determine the exact value of the trig ratios for larger angles whose reference angle is 30 degrees, 45 degrees, or 60 degrees. Okay, so any bigger angle, guys, that have one of these special angles as its reference angle, we can determine an exact value for those. Okay, and so why is this? Let's do an aside. We'll do this for the 60 degree angle. Okay. If we put the 60 degree angle into the first quadrant, I would have the 60 degrees like this. It's kind of like I'm putting that whole triangle right here. And so what would happen, guys, is this distance is 1, this is root 3, and the radius is 2. And so the coordinates of this point are 1, comma, root 3. I'm just going to pause for a second. Okay, I'm back. So in the first quadrant there, sine of 60 degrees is equal to y over r by definition. The y coordinate is root 3, and the r is 2. Okay? And I'm just going to simplify my diagram here a little bit. Let's get rid of some of these helper spots. Okay, and so now what we'll do, guys, is we need to reflect that point into quadrant 2. I'm just going to give us a little bit more space here because I got to fit in 2 more diagrams after this. Okay, so just imagine like reflecting this point over the y-axis, and we're going to reflect it this way so that we've got a reference angle of 60. Reference angle 60, that means that our rotation angle, our angle in standard position, is 120, right? If you do some small bit of geometry there. And if I'm just moving this point 1 root 3, reflecting it over the y-axis, it would be negative 1 root 3 over here, and the radius is still 2. Okay, and so in quadrant 2, then, it is sine of 120 degrees, which is equal to y over r, and the y-coordinate is root 3, and the radius is 2. So notice we get the same ratio. Okay, so we're getting an exact value for this larger 120 degree angle, and we're able to do that because its reference angle is 60. Okay, in quadrant 3, the angle would look like this. Angle theta, the 60 degrees is here, and we have to come up with what this point is. Well, it's the point negative 1 root 3 flipped below the x-axis. So it's still negative 1 in the x direction, but now it's negative root 3 down here. And the angle theta is, remember how it's 180 to go from positive x-axis to negative x-axis, 180 plus 60, so the theta is 214 degrees. And so we would be doing, 240 degrees. Sine of 240 degrees is y over r. The y is negative root 3, and the r was still 2. Okay, so we're getting an exact value for sine of 240 degrees. And we will finish off with quadrant 4. Let me give myself a little bit more space there. Okay, so the angle is like that. The reference angle is 60. It's kind of like I'm taking the 1 comma root 3 and just flipping it down. So it's still 1 in the x direction, but it's negative root 3 in the y direction. And remember, it's 360 degrees all the way around the circle, and so if that's 60, then the remaining angle is 300 degrees. So sine of 300 degrees is y over r, the y is negative root 3, and the r is still 2. Okay, so you can see all of these bigger angles, guys, that have a reference angle of 60, they ultimately have the same ratio as sine 60. They may just differ by a plus or minus sign. Okay, so using that reference angle sine 60, we can get exact values for larger angles that have that same reference angle. Okay, and of course the positive or negative situation comes down to the cast rule yet again, right? And you know how cast goes like this. Okay, so in the first two quadrants, all trig ratios are positive and sine is positive, so that's why in these first two we were getting positives. And then in quadrant 3 and quadrant 4, sine is negative, because just tan is positive and just cos is positive, so that's why we were getting negatives for those. All right. So let's check out example 3 then. Determine the exact value of each of the following. Okay, and so if we're going to find exact values, we have to hope that the reference angle for these bigger angles is either 30 degrees, 45 degrees, or 60 degrees. Okay, because those are the three that we have exact values for. All right, and so 135 degrees would be somewhere in here, right? Okay, which means the reference angle is here. And we know to get all the way to this line is 180 degrees, so you would go 180 minus 135, and lo and behold, the reference angle is 45 degrees. Great. So cos of 135 degrees is equal to cos of 45 degrees with perhaps just a negative sign in front, depending on the cast rule. And so if I write the cast rule, the only trig ratio that is positive in quadrant 2 here is sine. So it would have to be that cos of 135 is equal to negative cos of 45. And cos of 45 degrees is 1 over root 2 from the special triangles. We'd have to look at the special triangles again. It goes 1, 1, root 2, 45, 45, 90, and you can see that cos of 45 degrees would be 1 over root 2. And since it's the negative of that, we would put a negative in front. Okay, how about sine of 240 degrees? So we have to come up with the reference angle. There's 90, 180, it's 270 to the next line, so 240 is like so. And we know to here is 180, so to get the reference angle, I have to go 240, take away 180, which is 60 degrees. So the reference angle is 60. So sine of 240 degrees is equal to sine of 60 degrees with possibly a negative sign. Cast. The only trig ratio that is positive in quadrant 3 is tan. So sine of 240 will be negative. That's sine 60. Okay, and we know that sine 60 it goes 1 to root 3. Sine 60 is root 3 over 2. So we are going to get negative root 3 over 2. That's for sine 240 degrees. All right, example 4 is determining trig ratios of quadrantal angles. A quadrantal angle is an angle in standard position whose terminal arm lies on one of the axes. Examples are 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360, and so on. Okay, so it's the terminal arm lands right on one of the axes. That's what a quadrantal angle is. We could draw a little diagram. See, like an angle like this, that's 0 degrees, right? And then when you move up to here, That's 90 degrees. And move to here. That's 180 degrees. This is 270 degrees. And then when we get all the way back around, that's 360. And you can keep going, actually. The next one would be add 90 to that. 450, 540, 630, 720, 810, 900 degrees, and so on. Okay, so those are quadrantal angles. And so what we're going to do here is recall the formulas for sine, cos, and tan. Oops. Sine theta is equal to y over r. Cos theta is equal to x over r. And tan theta is equal to y over x. And for simplicity, let's use a radius of 1. Then the formulas become sine theta equals y over 1, which would just be y. Cos theta would become x over 1, which is just x. And tan theta is y over x. So using these formulas and the xy plane to the left, let's fill in the chart below. Okay, so we're going to have a radius of 1, which means to go from the origin to this point, this would be the point 1, 0. And that would be showing an angle of 0 degrees. And so sine theta just ends up being the y-coordinate because r is 1 and you're doing the y-coordinate divided by 1. Okay, so sine of 0 degrees is the y-coordinate, which is that, so 0. Cos of 0 degrees, cos is the x-coordinate, so cos of 0 degrees is 1. Right? So sine is the y-coordinate, cos is the x-coordinate, and tan is y divided by x. So we would be going 0 divided by 1, that would give us 0 as well. And now we are going to transfer this point up to here. This is a 90-degree angle, and this point has coordinates 0, 1. So sine of 90, sine is the y-coordinate, which is 1. Cos is the x-coordinate, which is 0. And tan is y divided by x. 1 divided by 0 is undefined. Then transfer the point over to here. The coordinates are now -1 and 0. This is 180 degrees. So sine of 180 degrees is the y-coordinate, which is 0. Cos of 180 degrees is the x-coordinate, and tan is y divided by x. 0 divided by -1 is 0. Transfer down here. The coordinates are 0 for x, -1 for y. And this is 270 degrees, right? The angles go 0, 90, 180, 270. Excuse me. Sine of 270 degrees is the y-coordinate, so -1. Cos of 270 degrees is the x-coordinate, which is 0, and tan is y divided by x. Negative 1 divided by 0, which is undefined. And we get all the way back here, which is 360 degrees. And we're back to the point 1, 0. So sine of 360 degrees is the y-coordinate, which is 0. Cos of 360 is the x-coordinate, which is 1. And tan is y divided by x, 0 divided by 1, which is 0. Okay, and then you can kind of keep going around the circle if you wish for larger angles. And actually, guys, if you go in the opposite direction, if you go around the circle clockwise, then you can start to define negative angles and do negative angles in the other direction. Okay, and this little chart here actually can help us to establish a graph for y equals sine x, or y equals sine theta. 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And you look at this and you go, okay, sine of 0 degrees is 0, so we have that point. Sine of 90 degrees is up at 1. I'm just looking at the chart. Sine of 180 degrees is 0. Sine of 270 is negative 1. And sine of 360 is 0. Okay, and I mean, we could fill in the other points by doing like a table of values and stuff, but the main points like this sort of show that shape, and that's why it's called a sine wave. The graph keeps waving to the left and the right. And y equals cos theta is very similar. If we start off here as 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, and we get 1 and negative 1. Notice that cos of 0 degrees, it starts up at 1, and cos of 90 is 0. Cos of 180 is negative 1, cos of 270 is 0, and cos of 360 is back up at 1. Okay, and we get a wave going like so. Okay, and so that's why we call them the sine wave and the cosine wave. Okay, and tan is a whole lot different. Okay, but you'll learn more about that in Pre-Calc 12. Okay, we are finally on to the last page. With all of our trig knowledge, we can now solve for angles given their sine, cosine, or tangent. This is called solving trig equations. To do this, we follow these steps. Number 1, determine the quadrants the angles will be in by looking at the sign of the ratio and using the cast rule. 2, determine the reference angle. It's always between 0 degrees and 90 degrees. And draw a rough sketch in the appropriate quadrants. The reference angle is found by doing second function sine or second function cos or second function tan of the positive value of the ratio to the right of the equal sign. Okay, so you always do it of the positive value to get the little reference angle. And then determine the rotation angles using the reference angle and the quadrants. So what does that mean? Example 5, solve each of the following for theta. And I'm just going to remind us of the cast rule. Okay, so we have sine of an angle equals positive 0.5. So you have to ask yourself, where is the sine ratio positive? Well, all ratios are positive in quadrant 1, and sine is positive in quadrant 2. Okay, so this sine of this angle being 0.5 could happen in quadrant 1 or 2. Okay, so you can have an angle in here. Okay, or it could be an angle there. And so what we need is the reference angle, because using the reference angle you can get any of the angles in any of the quadrants. So the reference angle is sine inverse of the positive value to the right of the equal sign. It's already positive. So let's see what that is. And notice that they want the answer to theta between 0 degrees and 360 degrees. So we want our mode in degrees. Good. So I go second function sine 0.5 and I get a reference angle of 30 degrees. Wonderful. So the reference angle is here, 30 degrees. In the first quadrant, the reference angle is equal to the angle itself. So we can say, therefore, theta is equal to 30 degrees in quadrant 1. In quadrant 2, it's going to be the big angle. We know how to get to there is 180. So the remaining piece is 180 minus 30, which is 150 degrees. Okay, and so those are our two angles. So if we check that, guys, sine of 30 degrees should be 0.5, and sine of 150 degrees should be 0.5. Wonderful. Okay, letter B. Cos of theta equals negative root 3 over 2. So where is cos negative? Well, we know that cos is positive here and here. So it's negative in those two quadrants. So this angle has to be in quadrant 2 or 3. So we have to have an angle like this that will give a cos of negative root 3 over 2, or in quadrant 3. Okay, so we need to get the reference angle, because once we have this little reference angle here, then we can use it to get the rotation angles. So the reference angle is equal to cos of positive root 3 over 2. Okay, if we make everything positive, that would push the angle into quadrant 1. And remember, the angle in quadrant 1 is equal to the reference angle, so that's how we get the reference angle. Sorry, and it's cos inverse, right, to get the angle. So we go second function cos square root of 3 divided by 2, and we get, 30 degrees again for our reference angle. You're not always going to get 30 degrees for the reference angle. So there's the reference angle. So then the two rotation angles are, this would have to be 150 degrees, and the other big one would be 180 plus the 30, so 210 degrees. And let's check. Cos of 150, it's not going to have it nice and perfect for it. It's going to have that. And cos of 210, first of all, are these guys equal? Yes, they are. Does that equal negative root 3 over 2? Yes, it does. Okay, so we just got that one as well. Okay, and finally the last one, cos of an angle equals negative 0.6753. Where is cos negative? Well, we know it's positive here and here, so negative here. Again, we are going to be in quadrant 2 or 3. Okay, so an angle here. Or here. So we have to get the reference angle. The reference angle is equal to cos inverse of positive 0.6753. 0.6753. And we get 48 degrees. So 48 degrees here and 48 degrees here, roughly. We have to do some rounding for this one. Okay, so angle theta is, you'd have to go 180 minus 48, so 132 degrees. And in the other guy there, it would be 180 degrees plus 48, so 228 degrees. Okay, so there you go, everybody. That is lesson 5 for trigonometry. The homework is from the Pre-Calc 11 textbook. So again, give those a try. It's on my website. Answers are at the back of the book to help guide you. And I will do a video answer key for you and post that later in the week. All right, everybody. I will talk to you soon.